Okay,
Are we taking extras?
it's in science class. Okay, so I would like somebody to remind me what a chord is. Paxton, what is a chord?
A segment with.
Okay, a segment with endpoints on the circle. How about a secant? Ready? Okay, a line. So it has like arrows. A line that goes through two places on the circle, like through the circle 2 times. Okay, a tangent.
It's like a line outside of the circle. That like.
Here.
It's like instead of the circle, it's like that.
Okay,
Just through the points of tangents.
true. But how many times does it hit the circle? 1 time. That's what I needed. Okay. So we have some theorems that deal with the length of these segments. Bryce?
Yeah, it's kind of like. Oh, you won't even have it.
I think Bryce doesn't believe me. Okay. Maybe that's why. Hey. All right. Segments of chords theorem. I want you to highlight this or like circle it. Circle it would be fine, or highlight it. Okay. So I'm going to kind of color coordinate here. EA times EB equals EC. That's pretty terrible. Times ED. Who could describe to me what is happening there, Ben?
I just have a question. So like, if it's EA times EB, like how does that help us with the length? Like how does that help us find?
So if one of those is missing, we can label it as X and solve for it. I didn't have the tennis ball. Sorry. Okay. Who can describe to me in their own words what's happening here?
CDR intersected.
Okay.
I quit.
So how do we get that product? Like what's happening for the product? I wouldn't say that that's true. I wouldn't say that that's true. The segments aren't equal, but what is equal about them? The segments aren't equal. EA times EB equals EC times ED. Nothing's congruent.
How did you guys get blue highlighters?
Nothing is congruent, but
Where did we
the
have them?
products of their segments are the same. Neither do you. Go on.
I know, but like I feel like it should be like. I feel like you should tell people that they don't have the tennis ball. Or we just have another ball you throw it on.
Just check it. Okay, I would like you to draw this circle.
I actually think that if someone's talking about the tennis ball, someone else should do it.
Like,
And you don't have that.
and you don't have to touch it.
Draw this picture. Draw. I do. Draw the picture. Okay, note to self. Adria doesn't get a 10. I always need a pass through.
Yeah.
Scoot in.
It's too close.
Mm-mm. Like the whiteboard should be erased and put away.
What are you doing?
Nobody is in need of rulers right now. The rulers are for my 9th hour class. Leave them be. Okay, I need you to label. Oh, I guess this is, forgot to label this as N. Okay, NJ is X plus 4. KN is X. MN is X plus 2. And LN is X plus 1. Please label these pieces of the circle. I have something to say.
Plus 4.
I'm just telling you. I'm saying this is the problem.
What if like so are these like lines, are they congruent like from ML to KZ?
Nothing is congruent. These are just chords that intersect. If chords intersect, then we can take their segments and multiply them. So I can take these 2 segments and multiply them. I can take these 2 segments and multiply them, and that is what is equal. No, there is nothing that we can assume. It's just the way that it looks. So what we can do is we can take X times X plus 4. And that is going to equal this product. So X plus 2 times X plus 1, just like that. Multiplication is commutative. All that matters is that these 2 segments from the same chord are being multiplied, and these 2 segments from the same chord are being multiplied. Yep.
No.
Do you remember that day we like did some algebra? This is what.
Wait, is that after school thing for us?
Always there for you.
Thank you.
Okay, so this is the distributive property. Over here, yes, we are gonna have to FOIL. X squared plus 1x plus 2x. But what? Okay, Zach brings up a very good question. I'm gonna start just like. Since we are multiplying these 2 expressions together, if you have an algebraic expression with more than one term, it needs to be in parentheses if you're multiplying. Okay? So we have x squared plus 4x equals x squared plus 3x plus 2. What should we do? Raise your hand. So I can throw you the tennis ball.
Subtract the 3x from 4x.
What?
Cancel the x squared.
Okay, so we can subtract the x squareds because they go away. And then Carson said subtract the 3x over to the 4x. So x equals 2.
Yes.
Yeah.
Nice work. It is something that somebody noticed and can prove. So we could probably find a proof of it. And I can maybe send it to you. Okay, but it is something that is provable. Well, you raised your hand, I was tossing you the ball.
Like I drink a lot of water, now I can feel like the water like it's making noises in my stomach.
Okay, give me the ball.
I don't
You're gonna die.
it's like talking.
Plug in numbers.
No,
Find it.
no,
Why? It works.
that's not gonna be very efficient.
But it's gonna work.
It's,
I never felt this before.
what?
You just plug in 1 and then 2 and then 3.
That's not gonna be efficient. Yes. All right, go to the next page. All right, now we're gonna deal with segments that are secants and tangents. So they start on the outside of our circle and come through. Okay, go out to the hallway. Okay, when we have either two secants or a secant and a tangent, the length of these segments we can find by taking the outside segment times the whole segment, the outside segment times the whole segment, and they're going to be the same. What do I mean by that? Okay. We are going to take this outside segment EA and multiply it by the whole segment EB. And that's going to equal this outside segment EC times the outside segment ED. So I like to say outside minus whole, or outside times whole, outside times whole.
I thought like EA and EC were automatically.
That is only if they're tangents. And since these are secants, that's not the case.
So like, because it goes all the way through, that means.
That's exactly what that means. Thank you, Ben, for pointing that out. When we have tangents that are both coming from the same spot, those segments are going to be congruent. But since we have secants, that's not the case. Okay, so outside times whole equals outside times whole. Draw this picture with me right where it says notes. I have a circle and I have two secants. And I am telling you that these are the measures of these four segments.
So, didn't we just did 9 times 11?
Nope. So first of all, I just want you to draw this. I want to give everybody a chance to draw it.
Is it 9 times 20 and then x times 10? Or 10?
Almost.
99.
No.
Oh.
Okay. Do you have a question? I'm waiting for you.
Well, is it 9 plus 11 equals 10 plus x?
Not quite. Okay. What is the length of this entire segment right here? Okay, thank you for not talking with the ball.
Yeah, so you do that.
This entire segment would be x plus 10. But we need to take outside times whole equals outside times whole. So the outside of this secant is 9 times the whole secant is 20. And that equals the outside of this secant is 10 times the whole secant. Since it's more than one term, we gotta put it in parentheses, x plus 10.
So it was right.
You are half right because you didn't get the product. You only said plus. There was no times. Okay. Okay, so now we need to solve this equation. 9 times 20 is 180. And then when we distribute, we have 10x plus 100.
8.
Not yet.
I didn't, no.
I'm gonna start just,
Yeah, do
You
it at
should.
8.
what?
She handed me.
Okay.
And then she like took it right on my.
Did you, hey,
I didn't distribute, I just.
I- did you divide by 10 first? Okay, that's perfect. Did we get to the same place? Okay, now, when we have, see if you get the tennis ball again. Yeah.
Back now.
This picture has one secant and one tangent. We are still going to say outside times whole equals outside times whole. The only difference, Jonah, is that the outside and the whole are going to be the same measure because of the tangent for this piece. This, we're still gonna do EC times ED. Okay. Let me show you what I mean. Jonah?
So you're just gonna,
Yep,
you're just gonna square EA.
let me show you. Please draw this picture. Technically, yes, but I'm not gonna have you remember the square. I'm gonna have you remember outside times whole equals outside times whole. Hold on. There's nothing that's 20.
X equals 20.
Oh, x equals 20. No, it doesn't. Just shh. Okay, let's talk about outside times whole equals outside times whole. So first of all, this whole segment is x plus 5. Do you agree? Just shake your head, yes or no. Okay. So over here, when we say outside times whole, we're gonna say 5 times x plus 5. But over here, when we say outside times whole, the outside is 10 times the whole segment is 10. What do you think the answer is?
You don't have the tennis ball, Tyler. You're not the tennis ball.
Okay,
We don't have the hitting ball.
if we distribute the 5, we have 5x plus 25 equals 100. Okay, Adri, I think I'm reading her mind. She divided the 5 over first and then subtracted the 5, and that's fine. But either way, x equals 15.
Oh, I said it. But then I said it.
Uh-huh. Not yours.
That's what really matters.
Okay. My lovely humans that should not be talking because they don't have a tennis ball in their hand. I would like you to set up, but not solve. Just set up, but not solve on the next page, number 1 and number 3. Set up, but do not solve. I am lifting for a moment the tennis ball rule so that you can speak to your elbow partner about the setup.
Ms. Holman, So for this theorem,
Yeah.
if you have a circle that has like this
set it up.
and this, that one's obviously smaller. So would it still this times
Yes,
this
I'm getting
equals
out.
zero?
Yes. It's proportional.
Miss Holmes, my mom texted me again, can I check?
X squared plus X equals 30. Yep.
Heck yeah. I wasn't paying attention for the first time and I still understand it.
Can I check what mom texted me?
I was wrong. Compromise. They're drawing, they're paying attention, and you know, it all works out.
Okay, do 3 now.
3.
All right.
Very good, very good.
Everything okay?
Yeah.
You guys have questions?
Yeah, but I'm going.
Oh,
I'm going out of town.
oh, yeah.
Huh?
Where you going?
Kansas.
To where at Kansas?
Yeah,
Do you have soccer?
yeah.
Are you playing with the O9s?
Yeah. They're paying up for years.
I told you just to set it up. Okay, 30 more seconds and then we're gonna do the algebra together. You okay, Ben?
And I don't know how to do the other stuff.
There's so many formulas.
There's so much stuff to like keep doing, and it's just like piles on. Wait, genuinely, like the stuff that I already know.
Yesterday. During play. Yep, I'm good.
Yeah, I know, but now.
You told me yesterday that-
Yeah, I did.
Hey, bro. How far right now? Yeah, that was nice.
I bet you just free.
I might have shit it. No, I just shit it next to me. No. No. Oh. Yeah, they got it.
All right, we are back to the tennis ball rule.
Where's the ball go?
I have it. Oh, there's a. I couldn't see Layla and she was hiding. She's good. All right. All right. I would like to know how to set up number 1. It's really going for somebody who maybe hasn't gotten to talk today.
Me.
Colton,
Yay.
how do you do it?
X times X plus 1 equals 6 times 5.
Okay, very good.
Yeah.
Thanks. We're good. Okay, do you agree, Tyler?
Yes. Okay, so then the next step. 605 equals 2, no, x squared plus x.
Okay. All right, we now have a quadratic equation. And when we have a quadratic equation, what do we have to set it equal to? Good, you remember. So x squared plus x minus 30 equals 0.
Oh yeah, we had this.
Great question. X squared. X squared makes it a quadratic equation. Put the scissors and the rulers down.
Okay, you just like solve it.
I am.
Well, what, how do you have to quadratic equation?
That's how you solve it.
Like, what do you like?
Well, what is his name? This is my last.
Someone, I think I know it. He's asking if there's like.
I get that there's maybe some times where you can guess and check, but that's not very efficient when there's 2 answers, number 1, and when our numbers aren't as nice, okay?
Is there like a rule that makes it so you have to equal to 0? Like,
Yes, it's the zero product property. So, yes, because if we have a product that equals 0, we know they need to be 0 because anything times 0 is 0. So what we're doing, since we have a quadratic, we're gonna factor it. So we have a product that equals 0.
Why do we do that? Zero just like placeholder.
So this is the only product that we know is gonna work like this. So anything times 0 is 0. Yeah. Okay, I have the tennis ball. I have the tennis ball. Adrian. Okay, so a positive 6 and a negative 5 multiply to be negative 30, but add to be positive 1.
You're right. Why did you write school without the L? You put school.
Somebody erased it.
How do you get from x squared plus x minus 30 to 0 to x plus 5 times x minus 5 to 0?
I'm factoring. So I'm looking for numbers that multiply to negative 30 and add to positive 1. Positive 6,
How do you know it's positive 1?
because that's the coefficient right there. Okay,
Oh, yeah.
so what does x equal? X equals negative 6 and positive 5. Those are gonna be for names. Are we okay with this answer?
Yes. How did you get from positive 6 and negative 5 to negative 6 and positive 5?
X plus 6 equals 0. X minus 5 equals 0. But I'm not okay with these two. I'm only okay with one.
Oh, wait, so does it have to be 5? Have a negative? So,
Can we have a negative segment length?
no.
No. And so I got them. Since this is X. I know, I feel your pain.
Is that your?
We cannot have negative 6 as a segment length. Because Bryce and Emily and Carson all think they need to be. Okay, do you have a question as to why negative 6 is not okay? Since X represents this segment right here, can I have a segment inside of my circle with length negative 6?
Yes.
No, that's not possible.
No.
You can't have something that's negative.
Had another number
See this?
I love it. If this segment were instead X plus 7,
It got turned into negative mass.
if these were our segments, is negative 6 okay? Yes. So you need to go back to your circle.
We just some intense. It's intense.
It's Drew and Adrian.
Drew and Adrian's couple name would be Hey Drew.
Okay. You need to go back to the picture. Because if your segment lengths are like X plus 7, then negative 6 is okay. Okay,
Okay.
But what
I didn't have
happens if it is okay?
You don't have the tennis ball.
then you don't have to cross it out.
You're not holding the tennis ball either.
Oh,
You're all criminals.
are you holding the tennis
Are
ball?
you-
No, I'm not. Dalton.
If they both,
Yes, I am. At least I can.
if they both work, yes.
So, like, on my answer, I would just cross out 6.
Negative 6, but yes. And so 5's your only answer. Okay. I'm gonna give you a worksheet, but I only want you to do the odd problems.
What if we do the even ones too?
I want you to do the odd problem.
Can we do the even ones? That's enough?
The even will be
Oh,
your
shit,
homework
it's
on
gonna be a-
Monday.
Unless you want to do all your. Oh, my music is really loud.
Oh, give it a buzz go.
It's in the other ear. Oh, okay. And I just took it down. Wait, are we leaving? Oh, shit, yeah, time to go. Shit, mushroom coolers. You almost hit my eye. My bad. No, don't. No, you almost hit my eye.
Oh, no.
Right under my eye. Okay, ready, ready.
Where did mine go then? Oh.
Yes, it's not Chinatown.
Did everybody get?
I remember that.
Did you guys get worksheets?
Yeah, that's the best.
Why do I have so many?
No, Sharon. Sharon.
He just
No, I didn't.
acting like you're an alien.